All right, today we're going to brush up on our completing the square skills. These are skills you used in algebra, but they may be a little rusty. So to rewrite circle equations into that nice vertex form we were using on Friday, we have to be able to complete the square. So that's what we're going to focus on today is brushing up on our completing the square skills. Then tomorrow we'll rewrite the equations, and then we'll start reviewing for our final. We'll be finished with our circle content. So here, completing the square is when you're multiplying two binomials together that are identical. So if I double distribute, or last year you used the box method to multiply these out, I'd have x squared, 3x, 3x, and 9. So you'd have x squared plus 6x plus 9. Okay? This one, you'd have x squared. I'm going to have two negative 8x's, so I have negative 16x. And then negative 8 times negative 8 is 64. Or here, I'd have x squared. I'd have two 7x's, which is 14x. And then I'd have 49. Okay? What patterns do we see between the linear coefficient and the constant term? Okay, so how can I get from 6 to 9? Or negative 16 to 64? Or 14 to 9? So really what it comes down to is 3 and 9. 3 is squared to get 9 and doubled to get 6. Negative 8 is doubled to get negative 16 and squared to get 64. 7 is doubled to get 14 and squared to get 49. So the middle term, if they're ax squared plus bx plus c, if you take b over 2 and square it, that will give you c. Okay, that's equal to c. So determine if the following are perfect squares or not. So 2 is my b term. 2 divided by 2 is 1. 1 squared is 1, which is not 2. So this is a no. Here I have 6. 6 divided by 2 is 3. 3 squared is 9. Okay, so that matches. That's yes. Here, 4 divided by 2 is 2. 2 squared is 4. Okay, that matches, so this is a yes. Determine the constant value that would make the trinomial a perfect square. So again, if I take 12 over 2, that's 6. 6 squared is 36. Negative 6 over 2 is negative 3. Negative 3 squared is 9. This last one, we're going to get a fraction, and we're going to go ahead and leave it as a fraction. 9 over 2, if I square that, is 81 over 4. Okay, you just square 9 and square 2 separately. So on the next side, complete the square for the following expressions. I need, if I take 8 divided by 2, that's 4. 4 squared is 16. I need this to be 16. All right, so if I have x squared plus 8x plus 16, and then I still need to do negative 1 plus 16. Okay, I have to add it to both pieces. All right, so then I would have x plus 4 squared plus 15. All right, I made an error, so we're going to go back here. If I'm adding 16 here, I need to subtract 16 to keep it balanced, so that these would still total out to 0. So this should actually be minus 17. Sorry about that. All right, so here we're going to do the same thing. I'd have negative 5x. Half of this would just be negative 5 halves, and then we're squaring it. So we're going to add 25 fourths. And I still have my plus 2. And to keep this balanced, I'm also going to subtract 25 fourths. All right, so then for this part, I would have x minus 5 halves squared. Okay, and then I would have negative 4.25 for this piece. All right, so we're going to be using them with equations mostly, and that's what you focused on in algebra. So to do this, I'm going to go ahead and draw my line down. I need to move the constant term to the other side to start with. So I'm going to add something to both sides. So when you're doing an expression, you add and subtract to make it balance out to 0. But here to balance an equation, you add the same thing to both sides. Okay? So half of 2 is 1. 1 squared is 1. So if I factor this side, I would have x plus 1 squared equals negative 12. Now, if I try to square root this, I'm not going to have any real solutions. So there are solutions that you'll learn about later on. To negative square roots. They're called imaginary numbers. But for now, we have no real solutions, so this is not possible. So we'll just say no real solutions. Okay, for this one, I need to add something to both sides. Half of 10 is 5. 5 squared is 25. So that's what we're adding. Then here, if I factor this, I would have x plus 5 squared equals 39. So at this point, I'm going to square root, which is 6.2 rounded. But remember, it's positive and negative. You have 2 roots to every square root. So to solve this, or to keep solving it, I had to split it into 2. I'd have x plus 5 equals positive 6.2, and x plus 5 equals negative 6.2. So for this one, I would have 1.2. And for this one, I would have negative 11.2. So that would be, or those would be, my 2 solutions to this problem. And this one had no real solutions. Okay, so that's how we do complete the square. You learned that last year in algebra, and we'll need it tomorrow to rewrite some circle equations. So we are working on worksheet 2 tonight. We're going to go ahead and finish up our packet tomorrow and then start reviewing for our final. I'm going to go ahead and do the first one on your worksheet with you because I don't think the notes really went with our worksheet too well this time around, but we are using completing the square. So the first thing I'm going to do on number 1 here is put my x's together, my y's together, and move my constant to the other side. So here I'm going to do x squared minus 4x, and I'm going to leave a place to complete the square. So I've used these two. Then I have plus y squared minus 14y. I'm going to leave a space to complete the square. Then I'm moving this to the other side. So instead of positive 17, now it's going to be a negative 17. Okay? If I take half of negative 4 and square it, I get positive 4. So I have to add that to both sides. If I take half of negative 14 and square it, I get 49. So I need to add that to both sides. Okay? So at this point, if I factor this, I would have x minus 2 squared. And if I factor this, I would have y minus 7 squared. And on this side, I have 36. So this is my equation. If I rewrite it where it's closer together. This is my equation in vertex form or standard form. So my center is at 2, 7, and my radius is 6. All right, so that's how we're using completing the square to actually write equations in this form.